Hey everyone, welcome back to my channel EduVibe. Today we will start with the another topic of the Unit C electromagnetic radiations, which is the refraction, and we also talk about the index of refraction. So as you know, we're doing that unit, and in the previous lesson we are doing the mirrors. We are doing the ray diagrams, we do the mathematical analysis. So that was the topic for mirrors. Now we start with the refraction, and this topic related to the lenses, and in upcoming videos we are doing the lenses ray diagrams and the mathematical analysis of the lenses too. So let's start with the refraction. So what is refraction, and let's start with this. So you saw this picture over there. So this is a glass of water and we put the pencil in it, and you can see that this is like a little bit bend over there. Over there you see the bend of this, but actually there's not bend in this. So when we see that thing that the pencil is over there is straight and then there's a slightly bent under the water, so this is because of the change of medium. So over there's a something air medium. In this there's a air into this, but in this when they put in water, so there's a water is act as a medium. So there's a two mediums. When we're talking about the two mediums, and then we're talking about the refraction. So stick a pencil in a glass of water and it looks like a pencil bends. Did we just break the laws of physics by causing the pencil to actually bend in the water? No. Simply the answer is no. However, something did bend. So it was the ray of light from the pencil that reached our eyes. So there is a refraction occurring. There is a rays of light in this which did the refraction, and this shows like a bending, but is not actually bent. So this is a visual effect created by the refraction. So from here we can see the refreshing can be occurring at that time, which has a change in direction of the wave due to the change in its speed and its passes between the media. Media means, so it's this different medium over there and we have a different medium over there. So it's a changing of the media, and there is a change of speed too because of the refraction. That's why this will happen. So when light passes from the air to another medium, which is the water. So here's the air over there and here we have a water. Not all the light will pass through a new medium. Some of it will be refracted, initially reflected, and some of it will pass into a new medium where the light will bend and partially refracted and experience the change in speed. You can see over in this diagram that this incident ray goes over there, and this going to the reflected ray, and then we do the reflect. And in the other medium, if there's a first medium, this is the second medium, and in this the little bit bend over there and they go the reflected ray, and this will become the point of incidence, and we have a point angle of refraction. All the things are same, but we add something new in this, that when they change it to one medium to another medium, they will do the reflection like this, but they also do some refraction like this, and they made the reflected ray in this. In refraction, we will have incident ray in the original medium with an angle of incidence. As we also said, this angle of incidence, angle of reflection, reflected ray, incident ray, and we have the normal in this. And normal line and the refracted ray in the new medium. We got the refracted ray in the new medium with the angle of reflection which is related to a normal line. Normal line stays this the same, which is parallel to all the things. We got the angle of refraction and the reflected ray, and this is our point of incidence. So in that case, in the first case, we have a less refractive area, but when we move on to the second thing, we have a more reflected area. So where is actually reflection occur? How much of the light bends related to normal depends on the index of reflection of the medium. So how much light should be bent, like this bending, how much it do in this related to a normal line depends on the index of reflection of the medium. So index of reflection is just something thing we have to find. So we have a formula for this too. And what is index of reflection? Let's take a look for this first. What is that? So index of reflection, or the reflective index, is a measure of how much light slows down when it is not traveling in the vacuum. So in that case, we don't have a vacuum. We have a mediums. We have a first medium, any medium. We have air, water, glass. We have a number of mediums. So here's the air, and then we have the water or air to air. So this depends. We're not doing traveling in the vacuum. We are doing traveling in the mediums. So in that case, how much light is slows down to it move on to the another medium with not traveling in a vacuum, that's the index of reflection. And is always denoted by this n, small n. When light travels in a vacuum, index is flow and it travels at c. So it's c. C means it's traveling at any speed of light in vacuum. Not actually the vacuum, but it light travels in a vacuum. So we take the c, which is the speed of vacuum, which has the value of this, and that n has no units, n is greater than or equal to 1, should be greater than or equal to 1, and this is index of reflection. In a non-vacuum media, light will slow down, v is less than c, and we'll want to have a measure of how much light it slows down. If n increases, the speed of light in a non-vacuum will decrease. So they have an inverse relationship, the n and the c, and we have that formula from here that n is equal to c upon v. V is the speed of light in non-vacuum medium in meter per second scale. So mathematically, this is our formula. We use that formula in this for the index of reflection to find the index of reflection. So that's all for the index of reflection in that part. We have two different medias. We're talking about two different medias. We always have two different medias or medium. So they depends on something. They have two cases. So what wave will light bend when it travels between the two different media? So there are different two possibilities to know about the two different media, how they act, how the light bends. So if the light is traveling from a medium with a low reflective index to a medium with a higher reflective index. So if we have a low refractive index and then we have a higher reflective index, they move from the lower to higher, we reflects towards the normal. So it's towards the normal. It goes much towards the normal, then goes to the not like they towards the normal. So this is the normal and they bends towards the normal, where theta 2 is less than theta 1. If the light is traveling from a medium with a higher refractive index, medium to a with a lower refractive index medium, so then the light will reflect away from the normal. This is the normal and this is away from. So theta 2 is greater than theta 1. So that will the lower to higher will towards the normal and the higher to lower will go away to the normal, away from the normal. And theta's values are different in that cases. And one thing more that we do in the questions and we have some mediums. When we talk about the air medium or talk about the vacuum medium, so the air index of reflection of vacuum and index of reflection of air is the same, approximately same, which is 1.00. So we always give 1.00. You will get the mediums, you will get the index of reflection if it is mentioned in the question. They give you the most of the times this, the index of reflection. Sometimes you have to find, so they give you the speed. Like in this example, the laser shown through water. Water has the index of reflection of 1.33. It reflects off a distant object and returns in a total time of the 183 microseconds. So determine the distance to the object. So we have to find the distance in this. So you know that v is equal to d upon t and distance is v times t. So we have time, but we don't have v. So we have to find the v in this. So for v, we have that index of reflection, which is n. So we know n is equal to c upon v. And we have to find the v. So v is equal to c upon n. C is your 3.00 into 10 raised to power 8 meter per second. And your n is 1.33. So you get v about 2.255 into 10 raised to power 8 meter per second. So this is your v which you use in this. So we get the v and the time is the total time. So it's the time of total it returns to. But we want for only one way time. So for one way time, we got 183 microseconds divided this by 2. We will get about 9.15 microseconds. So in this we have 2.255 into 10 raised to power 8 meter per second. Time is 9.15 multiplied by micro has the value of 10 raised to minus 6. This is in your formula sheet. This formula is also in your formula sheet. So you get about d of 2.0639 to 10 raised to power 4 meters. And we want 3 seconds. So 2.06 into 10 raised to power 4 meters. So this is your distance. So they're not commonly like they give those get question. They didn't tell you like find a v. They will give you like find the distance, find the time. So that's the thing you have to do when answering questions. So this will make like a 2 marks question. We have one more question. So this question is kind of a different one. And as I told you that you didn't have to get questions always. Like find the n, you have v is this. Find the v, you have n of this. So they will get you some different questions, not like get questions. So this question talking about the two different mediums. So we have a diamond, which is n is equal to 2.42. This is refractive index. Merged in the water as n is equal to 1.33 for cleaning. Determine a difference in the speed of the light for when the light travels from the water to the diamond. So there is a medium from water to the medium, water to the diamond. So we have to find the different velocities. So they mentioned about the speed of light for when the light travels. So we have to find the v for both, and then we have to find the minus them both. So for firstly for the diamond, so for the diamond we have n is equal to c upon v, which is c upon n. So this is 3.00 10 raised to power 8 meter per second divided by 2.42. You will get 1.239 into 10 raised to power 8 meter per second. This is for V for diamond, and for water do the same thing. C is 3.0 into 10 raised to power 8 meter per second. N is 1.33. You will get about 2.255 into 10 raised to power 8 meter per second. Now you have to find the difference. The difference means you have to find delta V. So for W, which means water, for D, which means diamond, minus this by time. So they're from water to diamond. So after velocity of water minus velocity of D, which is also the speed. So put the things, which is 2.255 into 10 raised to power 8 meter per second, minus this by 1.239 into 10 raised to power 8 meter per second. You will get delta V of about 1.02 into 10 raised to power 8 meter per second. Getting three digits. So that's how you can solve these questions. We got a different time. This is about the 3 marks question you get. So that's all you can use the index of reflection in the different questions. You have to memorize the theory which we do today, like what is diffraction, what are the two mediums, how they're different. So that's all thing you have to know. That formula is in your formula sheet. So yeah, so the theory part is again is in that topic too. So that's all for this lesson. In the next lesson, we will continue this diffraction topic with another law, with another formula, which is a Snell's law, which is very easy law. You have the formula, and the formula is always in your formula sheet too. So yeah, so let me say where do I learn smarter, not harder. Please like, share, and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till then, get it with EduVibe.